my screen once again, and so this is my slide for today. Okay, so I hope everyone what we discussed earlier in the session one, that you grasp all the things. If you have any questions in the session, in the previous session, if you have any issues or any doubts, then might be you can ask me directly today. Before going in depth about what just I want to wrap up what we did earlier and what we are going to demonstrate today, because it's a very interconnected and today is going to be a very advanced topic. So that is very important to be sync with the old concept, and after that we can jump to the next one. Okay. And yeah, parallelly, if you will do some discussions, if I will tell something, and if you have any questions, then I'm just reminding once again, you can put your questions, your message in your chat box, and once I will be back, I will check and I will try to give the answer all those questions. Make sense? So I'm just introducing quickly myself again. My name is Krishna Mohan Patel, and I'm doing here in. I'm founder of Arishna IoT Solutions. Also, I'm doing PhD parallelly, as well as we have a few of the projects that is the European Commissions, and also we are working with more of the United Nations projects like Parimundi Oceans projects for the species exploration using artificial intelligence, and also we are making some cybersecurity, blockchain implementations, and all those projects. So, okay, that's fine. I hope I'm just trying to quickly recap all concept of what we did in 5 minutes. So we discussed in the last session about the AI, how it's work, why cloud computing is important, what type of different clouds are there, what type of different architectural model like a public cloud, private cloud, and hybrid cloud. After that, we also discussed that how IoT cloud is works, because it's a connected concept, because nowadays devices are many more and sending the devices data continuously to the cloud. Then we are also understood how end-to-end IoT cloud concept is working from the sensor hardware to the cloud, and also we are getting the responses. In between, there is lots of communication is happening from the Wi-Fi communications to the internet. How we can do perform man in the middle attack, what is the DOS attack, theoretically we understand. Today also we will show some demonstration on it. Also we learn about that what type of sensors, controllers, how we are sending the data on the cloud. In the basic cloud, that is a UV dots, we learn already. We also learn about that how we are performing the analytics once we are storing the data, how we are doing how these data are useful to perform AI/ML, and if you can do some manipulation, then there will be lots of gambling can be happen, that with lots of malicious activities, unusefulness of the data can be possible. So those are all are interconnected to each other, right? So and after that we also discuss about why security is important in the cloud, what are the fundamentals like CIA, confidentiality, integrity, and authenticity. Those we discuss. We also see some visual demos, and we understood like how symmetric key, asymmetric key, hashing, and all those algorithm works. Good. And also we see the some demonstrations sending the data on the cloud in the normal encryption method, and like a normal cipher message and encryption method. Both way we learn that. We also did under discuss about different types of attacks, what is the usually the performing like a phishing attack, and also we discuss some other type of attacks in the details. And also we performed phishing attacks. You saw that how it is easy to make the cloning the page, and after that we can install the credentials. We also discussed that how we can do the DOS attacks, how we can do in the phishing, like, and how we can mitigate those type of attacks, like whose IP addresses. Then we are scanning the through the URL, we are scanned all the things, IP addresses, and we know that is it really genuine or it is not really genuine. So we can identify the malicious one and the genuine one. So this is the way we understand. Also, we have in the nowadays email filtering option are there. So if someone is trying to spam your like spamming through your email, then also it can filtering. You can do the set up your filters and all those things. So these are the small techniques that you can protect yourself from the malicious activities. If someone hacker is trying to attack on you or trying to manipulate you, then you can do that one. Other ways you can also in the firewall setup you can do in the network level. We can't cover whole things in this session, but whatever we will cover, we will my aim is to be understand properly all the security fundamentals mechanism, how we can do it. So step by step we will learn that one. After that, we have also seen that secure device to cloud communication, how we are encrypted data we are sending on the cloud, that through the Amartya. He is given the very beautiful demo. And after that, we see that today, if you'll get the time permit, then we will show also in the Azure IAM, like, identity access management system, how we can do the security transits on the AWS and Azure. So today we have enough time to all the things explore about that on major cloud services, that is the AWS and Azure. So we will see that how it is working, what are the mechanism, what are the protocols. Even AWS and Azure itself like a one certification program. There is a very professional, they are using that. But here I will just break down all the modules and I will tell you that guidance. I will give you the guidance how you can go and learn all the step by steps. And also we will in the end of this session also I will provide you the cheat sheet. So later on, if you want to do some practice on Azure account and all, then also you can create account, you can do some security practices, and you can create your own applications based on this. You can do that one. Last one is a defense mechanism. We are talking about what cloud security best practices, like these policies that we will discuss. IoT specific safeguard, how we can secure our firmware. That he told that the data, how you can secure, how is AI anomaly detection. So if someone will be do, then how it can be used. That also it is part of our demonstration today. Okay, good. So today now, because these are the basics, we are learn basic symmetric algorithms, asymmetric algorithms. But today that is not sufficient to do such type of practices. Just imagine what will happen if today quantum computer will suddenly launch in the market and everyone have a very good computational power. Then obviously the classical algorithm mechanism is not sufficient to handle such type of security implementations, because it's very easy for the quantum computer to decrypt all those data in the fraction of seconds. In that case, we have some other mechanism that is called post-quantum cryptography, and we will learn in this session how it works, what are the things. And but before that, we will also learn few of that existing classical encryption technique. So that is elliptic curve cryptography, that how it's a blockchain, because nowadays it's very famous, and people are continuously adopting this type of mechanism in the different type of applications. Like if you're talking about the Bitcoin, if you're talking about the different types of coins, Ethereum and other things, they are adopting this security mechanism. We will also discuss, like zero trust security. So don't trust to any IP addresses block, like every time you have to ask for the identity, then only it will allow to enter in the network. So this is the whole discussions. Also in at the end of this session, I will provide you that what is the research area in the academic side, what are the research area, basically the industry they are following the portfolios and other things. So those things will come also later. Okay, fine. So in this post quantum cryptography, I will start. And after that, I will like Prabhakar will show some other demonstration in the electric cryptography. But firstly, I will tell you how what is this, how its electric cryptography work, and what are the structure of it. Okay, just a minute. Let me firstly save the bandwidth. So I will, what I will do is just I'm switching off the camera here. So I will save my bandwidth so my voice will be more clear and it is good. Perfect. Just a minute. So yeah, and now let me see it once again. And we are here, and we are going on this. Perfect. MNIT slide. And here, this is the normal method for the. But before the post-quantum cryptography, I would like to be discuss about the elliptic curve cryptography in the cloud security, and after that we will be back on the post-quantum cryptography. Okay, good. So in the secure cloud authentication, like, that is basically providing the transport layer security. It is protecting electric cryptography in the this layer, and this is the main responsible for the network layer security. So here you can see so how it's works. So elliptic curve cryptography basically nothing but is providing the mathematical puzzle. So it's a number of the questions. Suppose it's a mathematical questions puzzles they are providing, and this is taking lot of computational power to solve this, and it is very hard. It is very because if it breaking from the attackers, it's very hard to solve this puzzle, and it's obviously the time consuming. Meanwhile, they will deny that, so it will be time will be out. So that's why this is the this technique is very adaptive, very fast, and that's why the people are using in the mostly in the sector who is where we need a transparency, like we have to see the ledger in the public domain, like transactions details and all those things, so they are adopting in this. Also, a few of the IoT like IOTA and all, there is a lots of other services, IoT cloud services. They are also frequently adopting these services, elliptic cryptography for the cloud security as well as. So that how encryption technique and all the things is working. So might be I would like to invite you to Prabhakar. So he is a application engineer, and he is also working with more on the AIML side and security implementation in the blockchain. So he will introduce more about the elliptic cryptography, and after that he will also explain that the denial of service attack, how it is affecting and how it's work. So yeah, it's Prabhakar. It's I am handing to you, and you can just explain about in the details how it's work. Okay.
Yes, yes. Am I audible?
Yes, perfect.
Okay, hello everyone. First of all, I am Prabhakar Joshi from New Delhi, India, and along with that, I am an application development and cybersecurity intern at Arishna IT Solutions. So, first we'll start with what does this term elliptic curve cryptography means. So it's basically from the family of cryptography techniques, many cryptographic techniques. So it is the one is this one is the elliptic curve cryptography. This one specifically uses mathematical functions, uh, specifically curves over. Not the it's not very infinite or very vast. So it uses mathematical functions over finite fields to provide encryption, authentication, or the secret thing, where two users can get a secret and they can agree on that instead of the original message, so as to ensure the confidentiality of the information along with maintaining the integrity that okay, this information is right. So first of all, what is elliptic curve? uh, we'll start with the demo for that, so it's easier for everyone to understand
Yeah, might
as
be you
we.
can share the screen, and after that you can demonstrate about that, and meanwhile you can also explain the terminologies parallel. Yeah.
Okay, is my screen visible?
Yes, perfect. Go ahead.
Okay, so here I have created a demonstration. We won't need to do anything. We'll just need to click these buttons and all, and we'll move through this as we explain everything. First of all, let's understand what is this elliptic curve function we are talking about. So this elliptic curve is a special kind of curve defined by a very basic equation, which goes like y square is equal to x cube plus ax plus b. It's very basic, but the complexity goes when we computationally solve it or add it into existing algorithms and all. So the points on this curve, this elliptic curve, These points are used combined with mathematical calculations and such as adding those points or multiplying them over and over again, which gives us a very complex end function, which is end result, which is very hard to decrypt. So it's very hard to reverse. And this entire process, this is called the elliptic curve discrete algorithm problem. uh, Moving on, uh, this this ECC uses this elliptic curve mathematics to secure the communications with the, uh, the keys that are produced by this algorithm, this particular cryptographic algorithm. Those are smaller than the standard RSA keys. These keys are not very big, but they ensure the integrity and availability of the information. So uh, it's a win-win situation for everyone. Let's first generate a private key and a public key. Private key, as we all might know, is something we don't share with anyone, and the public key is something we share with the someone we want to share the information with. So instead of the message, we share them the public key, and along with the signature, they can verify that okay, this message is correct. The found message is correct instead of looking at the message itself. Oh, and one more thing, that we see that WhatsApp messages are end-to-end encrypted, and it's also written that not even WhatsApp can see the message. So we'll see that here as well, that how does this entire thing go, that why can't even WhatsApp see our message and the encryption is maintained as well. So first of all, we'll generate a private key and the public key, and this PM stands for the privacy enhanced mail. As the name explains it, uh, it's just a naming convention that okay, this whatever mail we are sending, whatever the message we are sending, it's the privacy is enhanced in this. This is a standard. These standards are given by the creators of the uh, ECC algorithm. First of all, we'll generate a private key and a public key, and this begin private key and end private key. This is a standard format. This PKCS. It stands for Public Key Cryptography Standard. It's a #8. So this is a standard format for writing private keys or public keys like a word-based format for writing private keys or public keys. Uh, so as it is understandable by everyone and anyone and everyone. And here, as we discussed before, we are using the elliptic curve algorithm. So this ECDSA, this stands for the elliptic curve digital signature algorithm. It's the elliptic curve version of the digital signature algorithm. Like there are many more like RSAs and all, but we are not using that because we'll come to why we prefer this ECC over the RSA algorithms. Furthermore, let's write a message here that hello everyone, a very simple message, and let's just sign this message. Base64, as we all might know, it's the standard format for this is signing any message. So it's in readable format. Furthermore, we'll just copy this signature and we'll add it here. Okay, one more thing, that this even if I change a single text in this message, let's just make the E capital here, and if I try to verify it now, this verification will fail. The message will not be verified then. Instead, I'll have to send the exact same message. So if I'm sending hello everyone to anyone over WhatsApp, so I'll have to send the exact same message. This is how the backend verifies it. It's a very high level overview, but I hope it's sufficient to understand what's happening behind the scenes on a higher level, from a higher level perspective, what's happening behind the scenes. So in here I'll have to keep the format and all the text and everything the same. Otherwise the message won't go, the signature won't be verified. And if the message is or both the messages are equal to each other, then the verification will go fine. It will be verified. Okay. And furthermore, will coming to how the third party verifies, like if I am talking over someone over text app, if I am talking to anyone over the text app, how will the maintainers of that app verify that the communication is going fine without even looking at my message? So how does that work? If I if someone were to tell me about this, I'll see that it's not possible. But thanks to this elliptic curve Diffie-Hellman secret algorithm, this is possible. So instead of passing on the exact message to uh, the people who are let's say maintainers, Alice and Bob, let's say they are the maintainers of the chat application we are using, and instead of passing the original message for them to verify that okay, the sender the sender of the message sent hello everyone to everyone, and the receiver also received hello everyone. So instead of this message, they'll receive the public key and private key. Sorry, they'll receive the ECDH key, this elliptic curve Diffie-Hellman key, and furthermore, instead of getting the exact message, instead of getting this exact message, this hello everyone, what they will get is a secret. So this secret will be the same for both of them, both of the maintainers. So any maintainer who is going through this verification thing, that okay, is the system working fine, so this secret will come out to be equal for both of them. And if the secret is not equal, then we can say that okay, this is the error, and the message has some error, and we can reach out to the parties that okay, whatever you sent over our application, or whatever you sent over the internet, the message that was received on the receiver side, that was not which was sent. So this is the significance of this end-to-end encryption, that I don't look at the message, but I still know that the message that was sent, or the information that was sent or received on either side, is best of both their interests or not. This is basically the relevance, and this is basically the power of using this elliptic curve cryptography algorithms, or similar algorithms, instead of the standard RSA and all those things. And one more thing we might have noticed: the private keys and the public keys that are generated. This may look like they are very big, but they are very smaller than the. This pubs are also very smaller than the standard, if we are using any standard uh, cryptographic algorithms. So this also adds to the readability of the entire thing, the interact how the maintainers can interact with it, making the entire system more feasible, and fulfilling its purpose, basically, the encryption thing. So this was the elliptic curve cryptography demo from and also this P256. This is the name of the specific curve from the elliptic curve cryptography. This algorithm we are using, this cryptography method we are using, P256 is the name of the specific curve we use in from this cryptography method. So I hope it was clear that if now that when WhatsApp writes that all our messages are end-to-end encrypted, and not even the chat app can read that what the message was. I hope it is clear.
Okay,
Now,
for this encryption, can you show that how you did, like you have used some libraries or something? So little bit if you can explain of this
yeah,
file of, yeah,
yes, sure. So I have
maybe a
comprised
little bit
everything
in the
in
coding side. Yeah.
and I have comprised everything in a single place. Basically, we are using this. There are libraries for this ECC demo side. Uh, these are the diff functions. We'll go to the helper side. Okay, these are the functions from JavaScript. We are using this puff to 864 to generate the keys, and furthermore we go on to use many alongside these functions. We go on to use many other functions. This AB to hex. The namings are a bit odd in this, but they do fulfill the purpose. So uh, going through the code, it might not be very understandable only reading through it, but they do fulfill, these are the specific functions that do fulfill our purpose of going through the entire thing and understanding how this works. This is SPKI as a ECDH, and these all these are the specific functions we are using. And alongside that, the buttons and all are the wrapping everything inside the containers and all. We are able to get our hands on get an
Mhm.
hands-on understanding of the entire demonstration which is going through. I tried to keep the HTML and CSS everything and JavaScript everything at a single place, uh, not to go into the complexity of the code, but I hope it is sufficient to understand that going through the functions and all that what we are using
Exactly.
to attain everything.
Yeah, so basically this is the function of the library, like whatever we are using. And if you have some application and you want to encrypt those data, like for the sensitive data or some like the credit card or financial data, then you can do the encryption and you can store and you can do the authentication accordingly, like how here he did that. So the same way, but it's totally depend to your application to application, your use cases and all those things. And after that, you can use this library as a JavaScript. If you are a, suppose you are a front end or back end developer in the React developer or Angular developer, then you can use such type of JavaScript code and functions to develop such application. So that's great. Thank you, Prabhakar. And do you have anything related to say electric or blockchain related also, or
Yeah, yeah.
can
We do have a demonstration related to the blockchain side also, that if we are transacting over the internet,
might
or
be we
someone.
can quickly just overlap, like just a sum of all the things, and you can show that. That would be perfect, because we can correlate how it's used in the blockchain. So later on I can explain better way in that how it's work.
Correct, correct. So right now it is locally hosted on my system, the entire thing. We are using we are using functions from the Python's threading and the collections library. All these libraries we are using from Python to draft the entire thing. And what we are doing is essentially in the entire in this entire project, we can say that if let's say I want to perform a transaction with someone over the internet, and the specific person provides me with his wallet address. Let's say he's very uh, he's very well to do, and he provides me with a Tron wallet address, that okay, we can do the transaction over this. And we do know that uh, we have heard that these transactions, the wallet addresses, they are not very traceable. But this is a common misconception that these wallets are not traceable. These are the transactions are very much traceable, and using those transaction trees, the wallet itself becomes very traceable. And what's the point of being the entire thing being publicly accessible, and the whole concept of the decentralized ledger and all, if we can't even see what we are doing. So if I let's say this is specific person, this is a very random person. If let's say he reaches me out and he says that okay, I want to perform a transaction with you for some service that I have offered him, that he has offered me. So I want to pay him now, and I want to know the authenticity of the wallet address that he has shared. I don't know the person, I don't know where he's from. He just shared me a wallet address, and I want to know the authenticity of this whatever the wallet address he has shared me. So what I'll do is I'll go on to the this transaction explorer. I'll paste in his wallet address, and using a mix of generative AI and the transaction trees, the interlinked transaction trees of this particular wallet address, along with a wallet analysis, using generative AI, of course, we can get an insight of what is this wallet about. Is this used for illicit activities? Can I trust this wallet or not? Plain simple question I may ask, and I would need the answer to, is that can I trust this wallet or not? Herein, as we can see, I have got an artificial intelligence analysis of the entire wallet, and this is the transaction tree that is generated. Now, looking at the transaction tree, people who are into the finance sector, people who are into that field, will understand the entire tree, and they can give an analysis on this tree, that okay, this wallet is good or bad. But let's say we have a MSME business, or we are not very sound inside the finance domain of this entire thing. So what we'll do in that, so in the backend, what is happening that I'll show you. I'll show a stub response. In backend, what is happening is a JSON file is being generated along with the transaction trees, parsing the entire tree. That okay, this is the wallet. Wait, I'll show from here. It will be easier to understand. This is the from address. This is the hash, and consecutively these all the transaction trees up to 7 layers is being generated for the entire wallet. So this is the first layer, this is the second layer, this is the third layer. Alongside that, this is the I hope you get the everyone gets the point that looking at this transaction tree, a normal person may not be able to interpret what the wallet is about into the insights of this wallet is okay or not. But if we provide this JSON response to our generative AI we are using, along with a simple prompt that okay, I do own a business where I do frequent transactions. So if we do provide this, then the generative AI will give us an insight on the wallet, that is this wallet okay to perform transactions or not. So here, as we can see, it's written that two of its recent transactions originate from the addresses so and so, with complex and potentially obfuscating transaction histories involving many smaller transactions and subsequent transfer to the target address. So along that, it also says that it's an attempt to obscure the origin of funds. Basically, it's saying that this particular wallet can potentially be involved in money laundering practices or so. So looking at this analysis and looking at the transaction tree, one can say that okay, this wallet is not good for performing transactions. So this proves the entire concept of the decentralized ledger being publicly accessible and interpretable by everyone on the internet. Instead, if we used a decentralized system, if we were to perform a transaction on a bank account, very random bank account, so it is traceable. It is also traceable, but it's an hassle again. If we get defrauded in that transaction, then we'll have to move on to the authorities, and we'll have to perform the necessary activities in order to get hope to get our hands on what we have lost. But in this, before even the transaction is performed, we can look at the entire history and the entire insights on. We can get an entire insight on everything about the relevant wallet address. This is for a Tron wallet address. Subsequently, we can use USDT wallets or let's say BTC wallets. We just have to configure the application with the relevant API key. Here I have used the API keys for the the USDT and Tron wallets. This Etherscan and Tronscan are the name of the API providers. So here we have used these ones. If you were to perform a transaction analysis on Bitcoin or some other cryptocurrencies, we'll use the relevant API, and using the transaction trees, we'll pass on those to the generative AI we are using, and that generative AI will perform the wallet analysis for us. So that sums up I hope that sums up the entire process of how can we as a person who is not very sound inside the financial side of this transaction thing, we can perform wallet analysis on these relevant wallet addresses as well. And if any questions are there, we'd like to entertain those as well.
Okay, so it looks there is no questions, but that's perfectly fine. Thank you, Prabhakar, for this electric cryptography explanation and all those things. So it is really very helpful, because this electric cryptography mechanism, if you are developing something, the cloud infrastructure, or you have to maintain this ECC, because this is a very trendy security algorithm that we are using in the industry based setup. So this is very important. So yesterday also we are talking about most of the time DOS attack, and we are not able to share the demonstration because of the lacking of the time. So today might be because already Prabhakar is presenting. So I would say that Prabhakar, you can just demonstrate the DOS attack, how it's work in the simulation form, and how it's exactly the works in the real scenario, and also you can just show some how it's pauses and it's affecting the edge devices or might be the server,
Correct,
cloud
correct.
servers.
So right now, I'll perform the attack on my local machine. I hope
Hmm.
I'm audible. Yes, yes,
Yeah,
yes,
yeah,
sure.
please go ahead.
So right now we'll perform the attack on our local machine, like the machine I'm using right now. But it is a virtual environment, so the internet connectivity for the device which we are using for the meeting will not be affected. But my this system, this particular system of mine, it will be compromised. This virtual machine, it will be compromised. And how it will be compromised? So DOS, it stands for denial of service. As the name explains, denial of service, what service? So let's say I want to access the internet. Let's say I want to access google.com. So I'll ping google.com that okay, I want to access you, and would you provide me with the access? So if Google says that okay, I can provide the access, and if so for that I'll need to ask Google first that okay, would you provide me the access? But what if the entire road to reach google.com to give my message, it is flooded
Okay,
with very.
just sorry for the interruption. Can you little bit zoom it because it's hard
Oh,
to visualize? Yeah,
yeah,
just
sure,
little
sure,
bit.
sure.
Yeah, I
Is
hope
it
that is
visible
fine.
now?
Okay. Yeah, yeah,
Yeah.
yeah. Go ahead. Perfect. Thank you.
So when I am going to, let's speak in very layman terms, when I am going to Google to say that, hey Google, I want to access you, and let's say the road to for me to go to google.com is flooded with very garbage data packets, or it's flooded with uh, gibberish data packets which I have no relevance of. So it will be harder for me to reach to my relevant destination. For me to say to google.com that okay, I want to access you, I'll have to go through that road, but that road is already flooded with gibberish information, or uh, garbage, let's say. So it will be harder for me to go to that road, go to my destination, and would result in there being a delay in being able to reach my where I want to go. So that's basically, in very simple terms, that's basically denial of service. That if I want to access any uh, relevant destination, and I won't be able to access it because my local internet will be flooded with very garbage data packets, due to which I won't be able to communicate what I want to communicate, and in return I won't get the response I wish to receive. So right now we can see that this data packets are going out fine, and Google is also responding to my messages. 64 bytes of data packets, those are going, and I can say that okay, I am able to communicate to google.com. But let's say we run a wait, I'll open a terminal, and let's say there is a attacker who, this is my localhost, but in a similar in a public, when let's say we are connected to a public internet, and the attacker deploys this script. This is a very simulation script, very simple. It's just using the standard system functions from uh, the Python's SYS library and sys library. Let's say the attacker deploys this script uh, on my local internet, which I am connected to. We'll just type it here. Simulate.py. Okay, so this has been set on a timer of 10 seconds. So now if I go on to ping Google, it won't work because my entire internet, it's being flooded. Okay, the timer ended, and it's running fine now. Let's increase the countdown to 30 seconds. Let's say let's increase the countdown to uh, okay. I hope this will, yes. So now if I try to ping Google, it won't work because my entire pathway for my system to reach out to google.com and say that okay, I want data packets from your side, I want to communicate with you, that entire pathway is blocked. So I'm not able to even communicate Google because the intensity of the data packets is are very high. But on a public server, or what the attacker wishes to accomplish by this is to take down entire servers, take down entire databases, take down the entire cloud infrastructure that someone has built. For that, for mitigating these type of attackers, and the goal of these type of attack, this is not an active attack. The attacker doesn't wish to accomplish get their hands on some active information using these attacks, but they wish to compromise the systems. They wish to inflict damage on the infrastructures which are set in place for, say, let's say a stock market system. So if there is a denial of service attack based on those stock market systems, there will be loss of billions and billions of dollars if the system goes down. A client will want to perform a trade, but he won't be able to even communicate the system, and the price fluctuation will also not be visible. Due to these scenarios, there will be due to these passive attack, there will be very humongous amounts of losses that will be inflicted on the entire organizations or companies. So being a passive attack, DOS attack or distributed denial of service attacks, these attacks are very dangerous as they compromise the working of the organization. They let's say I'm working on an assignment, and someone comes into my room and snatches my notebook. It's a very basic example, but I hope everyone gets the point. What the goal
Ye-
of this attack is, and
Yes. Yeah,
just a
might be
minute.
you can little bit, just little bit also give little technical about what simulator tools you are using. That basically it looks like a Kali Linux. So just explain about that coding sites little bit and how they can do that. Obviously for the ethical is education purpose. So, but how it works and what are the backend like things, how we can defend the things and what are the things we can use for the defending mechanism. You can discuss also.
Correct, correct. So for the simulation, if anyone wants to learn about these tactics, or anyone wants to just simulate these type of attacks, uh, this is I am using Kali Linux right now, but it's not important to use. We can use any Linux distribution. It's just that this particular distribution, it already comes with all the relevant tools. We have every tool, so it's just more accessible than others. If we were to use any other Linux distribution, or if we were to use any other Linux distribution, we just have to install those relevant tools using sudo apt, or any relevant installers. If we were to perform these attacks on Windows environments, well, it isn't recommended because we'd have our data files and all, and these networks and all. It's just that for learning purposes, this will be more helpful. Instead of simulating these attacks on a Windows environment, we can use Linux environments. Will be more relevant for these type of attacks because the tools and functionalities all already available there. What we'll have to do is just write the scripts. It's just more handy, we can say. In one plain term, we can say that this is more handy. And instead of deploying it as a main operating system on our device, we can use virtual machines. We can use VMware, or we can use VirtualBox. It's a very good open source tool. It's a very good open source distribution of for simulating virtual environments on our local systems. So we can use those as well. And the entire purpose of using this is that our main system isn't compromised. It's the working of our main system isn't affected when we are using these virtual environments, and we fulfill the purpose of our understanding as well. If you want to learn something, that purpose is also fulfilled to our significance. However we want it to be performed. I'll just write a script, we'll use the helper functions, and we can simulate any type of attacks on our own systems, so as to not disrupt our existing whatever our workspace is, whatever our working environment is. That's why it's recommended to use these virtual environments. Furthermore, yeah, if there are any questions or concerns regarding this, we'll be happy to entertain those.
Yeah, you can move on because I'm just checking the chats. If some questions, then I will tell you.
Okay, yes, sure. So we were talking about that how are these DOS attacks mitigated? If I want to right now I am running these scripts on my own system. So 1 second. Okay, will use this one only. So this I can just press Control C and the entire thing will be disrupted. So how are these attacks stopped when we are on a public internet? So what will happen when on a public network these attacks are performed? These garbage data packets or these large quantity of data packets, these will come from a particular IP address. That IP address can be real or it can be fake as well. And what we can do, what actually it's a very good example, we'll go to it right now. This API rate limit. So these API providers, they have provided a rate limit that okay, these are the maximum number of requests you can perform per second on my server, on my local server. If anyone tries to perform, if any IP address tries to perform more requests on that relevant on that particular server, for the Etherscan or the TronScan APIs, that rate limit is set to 5. That's why we have limited our request rate to 5 as well. So if someone wants to flood my local system with these, they'll have to perform more they'll have to flood my local network with let's say 1,000 or 2,000 or 10,000 data packets for me to not be able to use my internet. Right now we are at I think 1,000 or 2,000. These functions, these relevant functions are using those. So if we put a rate limiter on our local system, local network, then those IP addresses, and we'll set a function that okay, if the requests are more than 5, if requests are more than 5, then block the relevant then block the IP address it is coming from. That way, this is one way of mitigating these attacks. Furthermore, using the several types of these cryptographic algorithms, those messages are also encrypted and all, but those I think those are for different use cases. But putting these rate limiters or putting these restrictions, we can mitigate these attacks on our local network, as well as if we are working with an organization, if we have an organization of our own, if we put rate limiters, this is the best practice for uh, uh, mitigating a DDoS attack. But what if someone what if our service requires 1,000 or 2,000 users running? So let's say we have a stock trading platform, and we require 100,000 active users. Inside that, if one user all the users will put 2 or 3 requests at a single time. But inside that, if a particular user puts out 100,000 requests coming from one IP address, that way we can identify those and we can perform the necessary practices that are required to block those relevant addresses. And these are basically insights into the strategies we can use to mitigate these attacks and to keep our system secure and ensure proper working of our entire workspaces. Thank you.
Mhm. That's really great, actually. Thank you, Prabhakar, for this wonderful demonstration on the DOS attack, and also you align with that how it's a DDoS attack as well. So also other sites, I just want to tell you that in the DOS attack, not only in that application site like where your application is hosted, also you can do on the router configuration or firewall configuration as well as. So in the firewall, you can just do a specific IP address. If you are in the private network, you want to allow only that specific IP address, then you can just give the access to those particular IP address. Otherwise, other just do it close and just open particular the range of those IPs. Second way, you can do just if you will found some pattern of this type of DOS and the same IP configuration or something. If you found some pattern internally and through the AI pattern recognitions, if you can get that, then immediately you can drop all those packets of the request. So basically, the DOS attack, that it's a continuously trying to jam your network, and they are just block your services whatever you are offering. So that is the, and this is very common prominent attack, like usually it's happened every time from the one country to other country, one organization to the other organization, and so on. Okay, that's great. Thank you so much. So, if you have any questions, any doubts related to the DOS attack, or might be the previous phishing attack, or some other questions, how we can do that. So, but Linux platform is a very good, setup to do all the things. Basically, that will support you the multiple open source tools provide you to perform some ethical practices for the understand the security mechanisms. So yeah, Kali is the one of them. Basically, in the college time also we are learning on this in the college. Kali Linuxes we are doing the practice, and now we are mostly working on these practices. Okay, now if you have any doubts related this, then we can discuss here. If no, then we'll take a small pause for the 5 minute, and after that we will return back, and we will again start with advanced encryption algorithms like post quantum cryptography. And again we are going back to the IoT cloud services, how we can implement those services. We have Amartya here, so he can also give more about how we can sending the data in the encrypted method. And in the last, you can saw that in the this UB dots, we are not able to decrypt, but AWS, we can through the command line, we can decrypt all those data, and we can see how it's work exactly, and how we can secure because there's multiple services they have, like a wall. And I told, right, AWS itself, there is a full security certification program inside that. You have lots of features in that applications. You can use it, and you can provide much more security, better security to your applications, right? So yeah, that's it for just we will take, and we will come again just 5 5. Okay, thank you.
Okay, sir.
Okay, can we start?
Yes, sir.
Okay, perfect. So, welcome back. So, here already you understand about ECC, you understood about the DOS stack, you also understand about multiple types of things, security mechanisms. So, here now the session onwards, we will talk about the post-quantum cryptography. This is very new trend. This is few people are thinking about this is not only acceptable by the classical computer, it is only might be implemented in the quantum computer. Then if you have also misconception like post quantum cryptography is only working for the quantum computer, then you are wrong, because it's not working for, it's not meant or implemented for a quantum computer. It's meant make the classical computer secure from the post quantum from the quantum computers. So just what I told earlier, if there is a quantum computer will come under the practice, like every user will use that one and frequently use that, in that time application definitely need to be much more secure than in that case. It can be for the quantum computer also, it could be challenging for them to hack those systems. For that case, for in that scenarios, that reasons, we develop this post quantum cryptography. So what is the post-quantum cryptography? Let's try to understand with this example. So we will just trying to compare between the normal encryption versus PQC. So if I will say the PQC, that understand that that is we are talking about the post-quantum cryptography. Okay, correct. So usually in the normal encryption, we are using either RSA, we are using SA algorithms, or many more, whatever the algorithms, classical algorithms we are using, that you are using that one, right? It's a, what you are, they are doing that they are just locking the number padlock, or quantum computers can, and just they can easily they can break down that in the fraction of seconds, or might be it will take 1 minute or 2 minute max if you have a very complex puzzle algorithm like elliptic cryptography and so on. So for now, for past 10 year to 20 year, it is perfect. Still it's perfect, no problem at all, but it could not be perfect all the time element, right? It might be tomorrow, if something will change, then it is really not perfect. So in this case, how it's work actually, how it will be the secure from the post-quantum cryptography. This is the side channel. You can see this is the traditional cryptography can be broken. So from here to here, if we are someone is mm, trying to attack with the attacker of the quantum computer, then they can easily break down and they can decode those those plain text messages or cipher messages in quickly. So how PQC, how this quantum cryptography, how it's designed, that it's a very hard to decode, right? That is the question is coming there. So for the locking the data with a super complex puzzle means there is a multiple ways to do. Either it could be the lattice based practices, or might be the error correction based code, or might be it is possible the multi-weight equations, right? So in this while using, so what is the lattice based practice? So lattice based practice is nothing but that is creating sorry, it's creating 3D puzzles, like 3D dimensions here, like here just I'm putting something, and it's is in the environment itself they are creating some 3D grids points, and it's finalize the shortest part of this, and he will say okay, just finalize the shortest path, and this is finding the shortest part is squared because this is in the 3D and it's not easy to find that stage. So which one is the shortest path? This is the one of the method. Second method is the error correction codes. So it's giving very hard defined, like some broken images, and he will tell okay, keep these images in the as it is. That is very hard for the normal computer. It's, and even it's very hard for the quantum computer to keep this image as it is, broken images to at is the same of the main image. So this is the way of the post quantum cryptography they used. Still that is in the under the development phase. There is lots of internal encryption technique they are changing and they are using, and that is still open research area for all the researchers and all the industry developers also. So usually the basic use how we are using here in the post quantum cryptography, I just use this normal example. Basically that is the library we are using, and later on might be our colleague Amartya will also talk more about this library, how it works in the real-time scenario and how we can send that. So what this in this we are using the Kuber 512, this cryptography algorithm, and this is the library we are using to generate the key pair, and we can encrypting, and after that you are using the decrypting. So these all the techniques we are using. So here we just taking the sensors, because we are mostly connected with the IoT cloud, and we are sending the data on the sensors values and all. So this is our basically the expertise, and how we are integrating this type of the advanced security practices in our solutions. So that's the main goal here. So here the humidity and temperature, you can see this is we are using through the collected, like last time also you saw that we are using these values, and after that we are retrieving the data sensors, we are getting the value of the data, temperature value and humidity value. Once we will receive this value, then we are encrypting with the value with the generate key pair, message, temperature and humidity. We are encoding with this message, we are creating the ciphertext and share the secret key with this, with the public key and private key, and after this value, and after that you can see this one. This is the coding, I'm explaining that. Might be you can do it practice if you don't have a census, also don't worry about that. Instead of this Adafruit, you are just using some random values or random messages, and you can decrypt that. Don't need to remember or take some screenshot. I will share this slide with you, so later on you can do the practice, and also I will share all the cheat sheet what we have. If we are not able to cover suppose some cheat sheets, then we will share, so you can do it later practices. Okay, good. So in this like a post quantum cryptography, you understand. So basically quantum computer, if you'll come, then they we can use the source algorithm for decrypt this type of messages, this type of network. So in the next demonstration that is given by the Amartya, he will show you that basically he will not show on this kit, but he will show how we can do the practice, the security practice on the AWS cloud, right? So AWS, why we use, because last time we thought UVD is not sufficient for basic practices, because we have to also do some vault key and all those things, identity access management, lots of features are there. And if you are doing the practice on the AWS cloud, if you understand, then also the other cloud is a more or less is the same structure. If you'll go, I will tell you how it is a more, we will do the also the in the last the comparational analysis AWS and Azure, so you can understand the better way how it's different from to each other in the different security mechanism. Okay. So in this demo, basically Amartya had took some PSQ security algorithms. He will send the data, he will decrypt, firstly he will encrypt those data, he will show that encrypted data, he will display the all description data, and after that this mechanism you can use either AWS or either Azure, and either any or might be you are developing your own cloud services, then also it is helpful for you. Okay, now it's over to Amartya. Might be Amartya, you can just demonstrate about your all encryption techniques, and what we have to do for, and what we have to maintain the security practices during the application development. Thank you. Yeah, are you there?
Yes, sir. Am I
Perfect.
audible?
Yes, perfectly fine. Go ahead.
Okay. Thank you, sir. I am Mohammad Roy. I am an IoT developer. I am from Kolkata, and today I will show you how this AWS IoT Cloud gives a glance. Okay, let me share this screen first. I hope that my screen is visible.
Yes, it's perfectly fine. Please go ahead.
So let's come to AWS Cloud. Let me first log out from here. And I will show you how to create an account and all. So you can also use this AWS to get all the data to decrypt yours and everything. So come to AWS Amazon. It's simply if you type in Google as AWS Amazon, It will come like this: Amazon Web Services. Click on the first link and go to create account. So simply we have to just sign up and all. Okay. So these are the things. So we have to give a root user email and we have to give an account name. So let's suppose, let me give one. Let's give a name and verify. So a verification code will be sent to your email and let's paste it. So now you have to give all the root user ID and password. So I am just using something. So now this is the thing. You only get this free one for free trial about 6 months, and you can go with that. For minimal usage, we can use that. So now this is the thing. We have to select it is for business or organization. If you selected business, please when you put the email, use your organization or school email, and if it is personal, use your personal email ID. Give it some name and all. If we give some name, let me see. If we give all those things, after that agreeing on the terms and conditions, there will be a page will come up asking for your card credentials. Don't be get afraid of that. Just put your card credentials. This includes that also a PAN card number with that card ID. It takes that for your identity verification if you are a valid identity or not. After that, they will charge 1 rupee in our Indian rupees. I don't know about the other countries, but in India, it will charge you 1 rupees and it will refunded after your account verifications. So then you are good to go. So let me sign in my one. So here you can see there is a thing is called IAM username. So what is IAM? IAM is usually we called as identity and access management. We now I will sign in as a root user email, but when an organization or someone will have that root user email that will accessed by as an admin, and while we are the users, we will use this IAM user ID and IAM password. So we can here in the IAM we can allow everything in the security parts and all. We can give policies, everything. So let me sign in first with my root user email. Give me some 2FA. Okay. So after that, when you log in, this will come to your site. So how you can access AWS Cloud command line. So this is how it looks. This is all. Here you can get your cost and usages, all your apps, AI apps, developers, and everything, trusted advisors, every single thing that will be listed here. I will go to the EC2 as my recently visited. Otherwise, you can go from all services. So let's check into EC2. So we are now using EC2 as a free tier services, as we have selected EC2 as a free service. Now, how you can use that command line? So when you launch an instance, it will give you all those things about which you are opted to use. So here you can give it a name. You can select which OS you likely to use, like Amazon, Linux, Mac OS, Ubuntu. There are everything listed. There are more or so, and then you have to select the instance type. Here you can, as I can select that Ubuntu, you have many ones to select, and it will be noticed that there will be written as free tier eligible. If you are using free tier, this will be free. Otherwise, you have to pay as you go. As an instance type, there will be T3 micro. Otherwise, there are many more like T3 nano, T3 small, medium, large. So this is actually free tier eligible. This T3 micro includes two version CPUs and 1 GB of memory to use. And here we have to create a pair of new key pair. So what this pair of keys are used to, when we try to connect as a SSH using our command line, this will help us. So if we use that create new pair, it will give us two more options like RSA and ED25199. We will use RSA as a normal one, and if you want to use as a PuTTY to use this cloud in a PuTTY terminal, you can download that PPK extension, or otherwise if you want to use as an OpenSSH, then you can download this as .pem. Now let me show you how you can connect. As you can see, this is my server is running, my cloud server. Now let me show you how you can connect with that. Let me exit first. So in the desktop, if I show you here, I have my key. Okay, that I have downloaded from. I have my key, mykey.pem. So let's connect with my cloud. So this will be my command ssh-i. Where is my key? It will be on desktop. So this is the name. This is the user ID we will use. This will be when you create this instance, they will ask you for that. You can name it anything you want. And this is the IP address. This is actually a public IP address. So we are, so everyone like us can connect to use that CLI. See, this is the public IPv4 address, and this is the private IPv4 address. I will show you later how this private and public ones work. So let's connect with this. As you can see, my terminal is connected to my cloud one. This is the name change to Ubuntu IP and the private IP address. Now, if I check the IP config, the IP address of the system, it will show you the private IP. If you use the SSH with this private ID, it will not connect. You have to use the public ID. Fine enough? Okay. Let's run into something more. which we will have to use. So we will use this AWS IoT code. It also comes with this AWS console. So this is AWS IoT. We can connect. So this AWS IoT we use as a MQTT broker. So we can also tell what is MQTT. So MQTT is a message transferring protocol which we will use as a for these data sending and receiving part. Actually, when we use MQTT, we use the terms as publish and subscribe. The client will publish the data and the subscriber will subscribe those data to fetch those data across some topics. So here you can see we can connect a device, IoT device directly to use as a broker. As of now, I don't have any devices, so I only used some other things. So let's come to manage under all devices and things. So as I have no devices, so I have created a thing as a things. So I named it as PQC device 1, and these apps, and when you create this one, it will create for you some really good things like the key, the certificates and all. This will show you like that. This is the CA certificate or certificate authority. This is the key we have, the private key we will use, and this is the public key to share the data. So now let's get into our code first. Let me show you. Okay, this is our client side. Okay. Okay, one thing I have to also check you on that. How you can. Okay, sorry. So these EC2 services have some security protocols also. We can configure that as our own. So let's turn to the security groups. Here you can customize these all things as your own. Now I am using this one. You can see I am accessing the SSH and allowing the port 22, and for the IPv4 I am allowing all the ports and all the protocols and types. So you can manage these all the things and customize it as yourself. As in the cloud security, you can manage like which device you want to get those data. You can manage everything you want in these inbound rules, also outbound rules, like from this server when the data will go out, which servers you have to make a authentic one. So these are all. EC2 is very much elastic, or we can say authentic and more secure one. So let's come to the client one. How we actually encrypted that temperature data using PQC. So here we have created a Python client, as I don't have any device now. So we have imported JSON random to randomly generate the, here you can see the temperature and humidity. We have to randomly generated data. We have PAHO MQTT client to use as a MQTT broker. We will use MQTT publish to publish these all datas. Here you can see we have used one what you can say module PQ crypto. Under that there will be a key exchange method that will be called Macalis 8192188. So let me introduce with that. Into the PyPy, everything I guess know about this PyPy one. We all install every other modules from these websites on Python. So if you search it here, PQ crypto, there will be a lots of things here. So let's come to the first one. This will be the PQ crypto, or you can see there is a thing post quantum cryptography. So we will be using today this. As you can see, we have defaulted this from as a pqcrypto.kn Achilles. This is the official PQ crypto GitHub profile. You can check out that also. So let's come to this. Here, what we are doing actually. Let's come to the server side and let me introduce with the server code first. Give me a moment. This is our server side code. So you can see all those things are actually installed like PQ crypto. This crypto thing we have also used. I will let you know later. Firstly, check these all the things, and here you can see this line called secret key.bean and public key.bean. You can ask why we are using this. So this public key.bean, we are using it as a channel. Okay. This public key will be used to communicate with each other, and the secret key will be secret within this cloud. After that, you can ask me how we can connect with that server with my machine's broker. So this is the endpoint we are connecting, and where from this endpoint is coming, we are getting this from our AWS IoT center. So let's come to the settings, and here you can see there is configure endpoint and manage your device data endpoint as well. It is showing. So let's come to this. This is our device we are using, and this is the domain name we are using. So that's why we are using this as an endpoint to connect to that broker. As a port, we are using 8883 as we are using MQTT TLS encryption. This is the CA path we are using. This is the certificate authority. This is the certificates, and this is the key. So let's come down and let me show you how it actually encrypts those data. So here you can see we have used in the server side, when you can see there is a called aes.new and all. We have used here KEMs on the message. We are using that from a ciphertext and encrypted payload. So these are all when we decrypt the message. If we come to the client side and how this all data will be encrypted, here you can see there is a method, or we can say function, that is called we use as an encrypt. Here it is, cipher encrypt plain text 16. So what we can doing actually, the client generates a random secret key like a temporary AES key. So now you can tell me what is AES. Let me show you again. Again, we come to PyPy website, search for Pi Crypto Dome. So this is the library we are using, Pi Crypto Dome. You can have that all documentations here. Let's come to the client part. Here we have used CryptoCipher as AES, and we are using padding to encrypt those data. So This will encapsulate this secret using the server's public key that I have shown you, named as public.key.bin. It is already shared with this machine. You after on the first run after the server, you have to share the public key with the client. So if I enlight something on AES 128, AES has some client and server things. This has a padding. The padding will do what? Pads the plain text like temperature and the humidity used for encryption and decryption data. It will encrypt the data into 16 bytes blocks, and the cipher.encrypt will encrypt that, and cipher.decrypt function will decrypt at the server end. So why AES is used, I have to tell you. This is efficient for the encrypting the actual data, works well with any size of payload, and combined with PQC derived key. So it is secured and hybrid encryption. So in this PQ crypto, or we can say post quantum cryptography, we are using this algorithm I have told you before. So what this algorithm will do, this algorithm will generate some keys, and on the client side it will accept and make a relevant channel to share all those data. So let me first run. Okay, let me see first the client side one. So the how it is decrypting all the messages. You can see the topic we are sending the data. This is PQT IoT data. I have told you before. On the connect client, the user data we have used the RC. The RC is used if the client is connected or not. If RC is 0, it will show it will disconnected. See here it is written. Also subscribing to the topic, which topic it is used to subscribe, otherwise the connection will be failed. The JSON will show you how the encrypted data is coming. It will be showing as the KEM ciphertext and the encrypted payload. Now come to these things, how the data is decrypted. So the payload will be decrypted decode. We are using this decrypted one. On the upper hand, the cipher.aes key is used to decrypt all those datas. Here we are also using this crypto module to use our AES, and here padding will be unpad to decrypt the data. Here you can see on the client side we are using pad. Also we are using that PQ crypto to generate the key pairs and everything. So let's run this code and check what it is showing to us. Let's start the server first. Okay, this is my code. We are using Python. So the key pair is loaded from the files as we are using that public key.bin. It is connected to the AWS IoT point that I have shared you before. The connected with the result is 0. This is like we are connected with the client, with the server, and the subscribe topic will be PQC IoT data. Let's run the client side. Okay, this will be better for you to visualize what is happening. So this is our client side key, client side code. We are running this client side code. As you can see, the sent PQC encrypted data will be like this, like KEM, KE ciphertext. And if we come to this, okay, something is happening. Give me a moment. Actually, while I am using this client, it gets stuck. Okay, I can stop it right now. Let me run it again. Yeah, now it's running. Okay, let me stop you and tell you what is going on. 1 minute. Here in the AWS, you can see our encrypted payload, like we are sending from the what I can say, this client side, this encrypted payload like this. You can see here that sent PQC encrypted data will be like this. That KEM ciphertext, KEM means key exchange method. This will be like this. This all big ones. And how this encrypted ciphertext will be treated in the server side. Let me show you also. So we have received that KEM ciphertext like this. I've showed you on the client side, and the encrypt. So the decrypted value is like this. So this data is shared from the client, but in an encrypted form. So the encrypted payload will be this, and the key we have used to encrypt that data is this, and the decrypted data is this. Thus, how we are encrypting our IoT data using PQC, as I am using this one, Michaelis, it is used to as a key exchanging method. So I can't directly encrypt the data directly using PQC. But what I am doing is, while exchanging the key pairs, like the private key, public key, I have showed you. Let me share with you that again. See, there is a thing called public key.bin. This is shared also in the client side. Wait out. So I can show you. See, this is the same file it is using, where it is using here. It is using as to encrypt the data to make a channel. So this key is if this key is used to encrypt those what I can say, this data. So what we are doing, we are using PQC, generating some keys, but those keys also are using to encrypt our IoT data, so it can be called as a hybrid encryption. So we are using both symmetric keys and asymmetric keys, both in a single instance. So this is all. If any one of you have any questions, please let me know.
Okay, thank you, Amartya. It's a really wonderful session. I really saw that all the things what is going on in the encryption and what you prepared for us. So yeah, any questions related to the any encryption, any library related or some tools? If it is not clear, then you can ask me here. So, or any discussion, any things you want to discuss, then it's open mic for you. Okay, then no question. Then quickly I will go to the other
The
part.
participants don't have the access to, they cannot talk to you. They can convey the
Okay, okay.
message in the chat box and we can convey it to you.
Okay, okay, perfect, fine. That's okay, great. Yeah, if you have any questions, then might be you can just put the chat message in your chat box. Then I will come back and I will try to give the answers of that. So thus you can see that all the things like a public key, private key, they are generated, and this is if they can open that one, that is also the same message what mm, Prabhakar shown you, that how to generate the public key and private key messages in the elliptic curve cryptography. This is almost the same way, but using the internal methodology is different, and they are using in the different libraries, and that's all those libraries basically taking care all those things. I hope everything is clear because we went very slow and a very crisp way. I think everything could be fine. But might be some of you have a question that okay, some of might be you have students or some research scholar, then you don't have a credit card, then it is quite difficult to do the practice on the AWS. Then you have other option that is called Azure. So this is from the Microsoft side,
Sir,
and
sorry
you.
to interrupt. Sir,
Mhm.
sorry to interrupt. But in the AWS, without the credit card, it can be also used. We can use the debit cards also.
Okay, okay, that's it. Because when I was used like a 1 year back or 2 year back, because AWS I'm not using much practice, but I have a practice usually in the Azure, and Azure now have a multiple options, but AWS I think now they changed the policies and you can use the debit card. But in the Azure you don't need to even use any debit card or credit card. You can use just a student account and you can use those practices like IMA, multi-factor authentications, wallet key, and private key, and some wallet key systems and other services, business intelligence, and all those things as per your need. So these are the things, basically the very latest topics today, and people are continuously improvising the post-quantum cryptography mechanisms, and they are doing that. So these are the trending research areas I found, and I will feel happy if you can collaborate with us in the different research topic and research areas. Basically, our team is working in the mostly on the IoT cloud and application development, and they are continuously developing and adopting new security mechanism as per the industry practices, as well as we are collidely working with the academia. So what are the current research is going on, and we are trying to implement those research in the industry best practice. So these are the basically the internal. So we are also working with some of the encryption topic like zero trust authentication, cloud native securities, AIML driven cloud threat and detections, blockchain enabled cloud securities, that Prabhakar is also leading on such type of projects. So multi cloud hybrid authentication, cloud securities, that like if you have some you are interested to work on the security policies across AWS, Azure, or GCP simultaneously, then also we can work on those areas together. Okay, now this is I found the very interesting paper for research, because most of the people I think you are faculty or research scholars, so that's why I little bit did small research on paper side. So novel framework to identify. So might be you can note down this one. This is from the Department Information System in the Business Analytics. I found this is from the Florida International Universities, and this is a very good paper I found. I went through it. So it's talking about all the security challenges, what are the opportunity in the organizational and digital transformation in the cloud side. So and this research topic also, they are given some standard framework and some comparisonal studies. So once you'll go, then you can get all the things. These are the report and studies in the latest last 1 to 2 years, and this is most of the global publishers like a Gartner. You already know about that. Thales also, he is a very writing good level articles. So they are also organizing like AI security and traditional security way. What are the tools they are using for the discovery? CSPM, cloud security for the Gartner also launched that one, and other global information security and forecast in this links. You will get it out. I will share this. Might be you will get more interest. So my basically role is here to kick off and make some interesting sites. What's going on in the industrial implementations, what we are using the methodology during the developing the applications and some other tools. Then we are what are the other tools we are using as the industry best practices. So these are the things we are exploring. Yeah, and after that, just I have a one quick cheat sheet. So that actually I did not, I think, get much time, but I will just want to overview about that, and after that you can do the practice top of it. Okay, good. Now, just let me see the file recent. AWS Cloud Security. I hope this is the one. Okay, so this is the one of the other Azure Cloud that I'm talking about, Azure IoT Hub. And this is the basically using X.509 certification. This is the same symmetric key and X05 like a private key and public key, sending the data and sending through the MQTT. It's very pretty much what Amartya shown, that it's a very similar structure. So also we have some practice on this. What are the advantage in this in the Azure? You can do the role-based access control. Also in the AWS, you can do the role-based access control with the AMS. Here is a called RBAC, where role-based access control, and you can do the identity access management. You can make some, and you can also block those what is that, devices, as per if that is not matches on the identity. Second one is the secure data flow. So you can send the data, you can to the cloud, and after that you can get the value in the encryption for some, like how it's showing the encryption and decryption by using the post quantum cryptography. Same way we can do it here also. This is the Azure threatened Azure based security center, like how we can defend the data. I will show you just quickly in this, might be in the last 5 minutes if I'll get the time permit. I will show you. And this is the end-to-end encryption. So you are just sending the data. We have Azure Key Vault though. So if you want to save your private key or public key, or something you want to lock with the vault key, and it could be decrypt with your there are multiple three methods are there. Symmetric key, their method is a X.509 encryption way, and other encryption way is also there. So just it's up to you how much level of security you want. So they are providing multi-layer security, so that is quite much better secure. So that's why Azure or AWS well known as, because they are providing security of that, and it is giving more trustworthy applications. In the other security demonstration that already you see in the AWS, so I'm just going through. So you already saw that, so security for the cloud, how we are so it is not allowing any other devices. It just only all time they will test that, okay, only this device is authorized or not. If the device is not authorized, then it will not accept those data in the cloud. Network security also, they have Azure have a firewall, so they can provide the security groups, and they can safeguarding of for those unmalicious accessing those data. Compliances logging, we have ISO standards. They are providing the on that some standards they are following, and to develop some applications. Data losses preventions, if you lose some data, because this is a server is multi-located. So if something will happen wrong, then you don't need to worry. You can revert back your data also. So AWS already is covered, so I'm just skipping this part. AWS, and this is basically the cheat sheet of AWS and Azure comparison. So I will share with you this one, and you can do some comparison. You can see this is a store secret and the secret manager system we are using in the AWS, but here we are using store secret key vault. I will show you how it looks like while I will log in with my credentials. Others, you can see this unrestricted inbound network access. So use security groups with the restricted inbound rules, like IP limit to your IP addresses and CIPDR. So these things you can do. On the other hand, in the Azure, you can use the network security groups, that is called NSG, and you can also limit your IP rules. You can write it down there. In the like a disable incomplete login, so you can trace all the activities. That is the best part in the both of them. So they are using cloud trial across. So mostly, all those features are available in the AWS and Azure. Only the things might be terminologies and names they did the changes. So that only. So if you are well known about Azure, then you can easily switch to the other practice. Only you have to do little practice on that, and you are used to it. Okay, now I'm just quickly jumping to my demonstration part here. Just I want to show how you can create this. So this is the Azure portal, what is the looks like, and this is the overall structure. I'm just trying to make portal.azure. Let's see. And here the good part is you don't need to make credit card or debit card. You can just use some your student account, or if you have already that, then you can also use a professional account. They will provide some free credits, so you can use till 1 year, and it's just totally free for you. Okay, so here you can create the resources, you can create the IoT hubs, and after that, once already I created that IoT hub, so I can show how it's work, how what are the policies you can configuration. So you can device, you can add here, you can you can add the devices, you can write your endpoints here. So if you want to send the data, then you can write your endpoints here. So you can also, you can do the routing, so you can write the message routing, so where if something conditions will happen, then what we can do that. So security second, because this is the main part actually, the entire session. So how we can restrict the security, how we can restrict the devices and all. So here you can see this is the networking based. So here you can create the policies, private access, and all those things. So you can create, so what are the all network disabled or disabled, select some particular range of that. So you can add all the filter rules, so you can add the IP filter rules and all those things, so it will restrict that one. This is really a very well planned structure for the security base. I would say that this is very planned for the everything, and it's a highly, I would say, secure if it is something we are working with Azure. That's why they are charging us, and it's quite expensive as well as. So but by learning this, protocols and all those things, that's why I demonstrate, like, module by module, so you can understand those things, how we can implement. And even if you want to go for the long term for your application or your services, then also you can develop your own cloud structure, your own services, and after that you can keep taking care about all those security parameters what we discussed so far in these 2 sessions. So it could be much more secure. Multi-factor authentications, IAM, how to avoid, how we can set up the configuration, like a firewall setup and all those things. Make sense? Okay, now we just also, you can see this, you can set some certificates here, and these are all details. Might be, I would say there's a many more, actually there are many more services. If you will click here, then you will see that there are n number of services they are providing, all resources and all. So you will go, it is just for one IoT cloud that we are frequently using these services for creating the demonstration and creating the applications for our clients. These are the IoT edge devices. This is also, we have pricing skills. So as per so Azure also, they are providing pay as per go. So how much as per users you need, how much message limits and all those things they're providing. So as per how much you are using your cloud, how much you need, as per those things you can set up your cloud infrastructure. That is also the best part. So if you have like your user is not very broad areas, then might be for the initial period you can use these services. That is also good, but in the longer it's quite difficult. Okay, and there are other security alerts, like Defender for IoT. This is also very one of the best feature for that. So you can use defending mechanisms like compliance view security alerts, and Defender for the cloud. So you can use your IoT solution for this. So you can create the security alerts for these devices, and it's selling turn on advanced threat protection and IoT solution. So yeah, you can go ahead and you can explore these things also. Okay, so And other than that is already you can see this number of messages used. So far you can trace everything. You can see all the cloud usages and in this dashboard. And later on you can, if you want to do some command line based, then also you can set up your configuration here. Okay. So yeah, any questions? Sorry, I hope I'm running out of time. So if you have any questions or any doubts, then you can ask me in the chat box. I will be happy. Or in the future, if you want to be joined, then I will just write up my email ID, or already might be you can connect with coordinator and he will give the details about us. Okay, in the last moment, do you have any questions? Anything? Then you can just text me immediately. Then we can discuss. If no, then I would say thank you so much for joining us, and I hope I achieved the goal what you're expecting from this entire workshop, and you got many more motivations, interest towards this security implementations. So that's it, and don't worry about this all the cheat sheets and presentations. I will share with the coordinator and he will forward to you everyone for further details. Okay, then. Thank you so much, everyone.
Thank you, sir. Thank you so much for the wonderful session. Also, all the participants, if they have any query, you can put it up in the chat box.
Mhm.
Okay, sir, it seems there are no queries. Thank you, sir. You can conclude, sir.
Okay, then. Thank you. So I'm just typing here my email ID. So in future, if you want to reach us, then that would be fine. And we are happy to be collaborate. Solutions.com. Also, you can reach us on my personal email ID if some personal queries, if you need some help. And just do the WhatsApp. I would just say that context if in the future if you need something, because my number might be will not work because I'm currently working in the Austria. So just WhatsApp us. So if immediate response, but it would be good if you have a detailed firstly do the email, and after that we can communicate further on the calls. So always happy to be do some joint publications, or if you are interested to do some like what do we say that exchange programs. Obviously in the Europe and India we did also like we have some young entrepreneurship programs we are doing that, also faculty exchange programs, student exchange programs and all. So yeah, please let me know if something makes interesting. Keep in touch with us, and so okay, then enjoy the cybersecurity. Thank you so much.
Thank you, sir. Also, to all the participants, tomorrow's session start at 9:30. Please join at the time. So you can disconnect.
Okay, fine.
Okay, thank you.